Michael reaction. So here we will discuss the general form of this reaction first, and then we will discuss its mechanism. You can see here, for this reaction we need alpha beta unsaturated carbonyl compound. So there must be a double bond in between alpha and beta carbon, and the compound may be carbonyl, may be nitrile group, or may be ester. So we can use, but important thing is there must be a carbon-carbon double bond between alpha and beta carbon. So this is our starting compound. Then we need actually active methylene compound. Active methylene compound means a compound having CH2 group and two electron withdrawing group A and B, electron withdrawing group attached to this CH2 group. So in presence of electron withdrawing group, these two protons are actually more acidic. We call this compound as a carbon acid. We can remove proton from this CH2 group by using a base, and we can generate carbanion. So if you want to prepare carbanion, you must select active methylene compound. So what are the reagents required for this reaction? We need alpha beta unsaturated carbonyl compound, and we need active methylene compound or any carbon acid we can use. So for this purpose, to form a carbanion from this active methylene compound, we need a base. And what happens? Addition takes place. So this reaction, this Michael reaction, is also called Michael addition reaction. What happens here? So H from methylene group is always added on the alpha carbon of the compound, and rest of the molecule is added on the beta carbon of the compound, and we get here an addition product. It is also called Michael adder. So this is called Michael reaction, or we call it as Michael addition. So this is actually 1,4 addition reaction. So this is actually 1,4 addition reaction. So you remember that I have not written here, but during mechanism we will see why this is called 1,4 addition reaction. Now see, we are going to discuss here one mechanism, but before that, as per this description, as per this definition, we have taken one example. So we have taken this compound. You can see here there is alpha and beta carbons, and there is a double bond between alpha and beta. So you know, this is a functional group, and next to this is alpha and this is beta. So I have taken this compound. That compound must have this moiety. So the compound may be CN, may having ester, but what is required? We want here alpha beta double bond. This bond on the alpha and beta carbon, the bond between alpha and beta carbon. Now as per the definition, active methylene compounds we need. It is actually the sandwich. CH2 is a sandwich between the two electron withdrawing groups. You can see here there are again carbonyl groups here in ester and here in this ester. So two electron withdrawing groups. So because of this methylene group, these two protons of methylene group become very active, very acidic. So we can remove this proton very easily by using a base. So here you can use any base which is having a lone pair. So I have taken here this base. Now this base can remove this proton very easily because these two protons are acidic, these two protons are active. So what happens? As I mentioned earlier, I have shown using this red line. So H, one of the H present on this methylene group is going to join here at alpha carbon, and rest of the molecule, you have to select rest of the molecule. Again remember, you just break this bond and join this on the beta carbon, remove that double bond. So just like this. So I remove this H and join at alpha carbon, and rest of the molecule, you can see a CH left here on this molecule. So this is the rest of the molecule. I join at the beta carbon. So I forgot. Okay. This is alpha and this is beta. So this hydrogen is added. This hydrogen is added at alpha carbon, and rest of the molecule from CH is now added on the carbon beta. So in this way we get this addition product, and this reaction is called Michael addition or Michael reaction. Now we'll discuss its mechanism, the path of this reaction. So the reaction is always started with the active methylene compound. You can see here active methylene compound is taken, and first step is acid base reaction. So our base is now accepting proton, removing this proton from the active methylene group, So this is also called carbon acid. So this is a carbon acid. Now you can see here this bond is now going to reside over this carbon as a lone pair. So if I put this lone pair on this carbon or bond pair on this carbon, from this bond a negative charge will develop here on this carbon. So this is carbanion. So active methylene compounds are good to generate carbanion by using this base. This is also called carbon acids. This is also called carbon acid. So this is actually undergoing different resonating structures that you can show. You can move this pair either here and open here and draw different resonating structure, or you can select another route to draw different resonating structure. That means this carbanion is more stable. So it is called enolate ion actually. So now after removing this base, I have taken a general base. You can take here, although I have taken a specific example of that base, but what is qualification of base? It must have a lone pair of electron, so we call it as a base. So base is now removing this proton and gets protonated. So this is the positive charge will develop over the base, and this is protonated form of this base. So this is actually conjugate acid of this base. Now once that carbanion is produced, you can see this is nucleophile. This is nucleophile or enolate nucleophile. So the nucleophile is generated here, you can say in another language. Now second step is addition of nucleophile. First of all nucleophile is added. First of all hydrogen is not added. First of all nucleophile is added. You bring that nucleophile here and bring your alpha beta unsaturated compound. So what you are going to do, you have to add this nucleophile. We will call it as a nucleophile on this carbon, beta carbon, by using this pair. So this pair is used to form bond with this beta. So this is a bond. So this is the newly formed bond by using this pair. Now to form this bond, this pi bond is shifted in between this carbonyl carbon and alpha carbon. And again, if you want to shift this bond here, you have to open this bond on the oxygen as a lone pair, which I have shown here. So if oxygen having 3 lone pairs, its formal charge is negative. You can count number of electrons, 1, 2, 3, 4, 5, 6 and 7 electrons. So because of this negative charge. Now this ion is generated, this anion is generated after addition of nucleophile. Now this nucleophile or this anion is ready to take proton. It is actually the base. It is ready to take proton from this conjugate acid which is generated in the first step. So by using one of these 3 lone pairs, it can abstract proton from this conjugate acid, and it will form bond by using this lone pair. So the 2 lone pairs left over this oxygen, and our base sets free. So base is now free. So this is base is now free. Now you can see here, this is nothing but the enol. Enol means what? Hydroxyl group, as well as in means double bond, and all means hydroxyl group. So this is called enol. So it undergoes tautomerization. How? That I have shown by using a curved arrow. This bond will move in between this oxygen and carbon to form a double bond, and this bond will move on this carbon, which is alpha. And as I mentioned earlier, we have to join there one hydrogen. In fact, this hydrogen. So this hydrogen is now changing position from oxygen to carbon. So that I have shown here, and we get our desired product, our final product. This is our final product. Now the question is why it is called 1,4 addition. Now if you consider this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is oxygen, means this atom is 4. So one part of this addendum, one part of this addition active methylene group is going to add at carbon number 1, and hydrogen, one part is going to add on this oxygen, which is a 4th atom. So because of this, we call it as 1,4 addition. So Michael reaction or Michael addition is also called 1,4 addition reaction. Thank you.